Okay, so today I'm going to look at probability, um, and so I think the first thing to understand. There's a number of things we can look at in probability, but I think the first thing we're going to look at is what do the numbers mean? Like, so you get like 0.1 and 0.7. First of all, why are they always under 1? What does that mean? Well, zero point 0.1 means 10% chance of something happening. 0.7 means 70. My pen's just waking up. 70% chance of something happening. So obviously, 0 would be there is 0% of something happening, and a 1 would be 100% of something happening. Now, if you think a bit about probability, you'll notice that there's very rarely 0% chance of something happening and very rarely 100% chance of something happening. We don't know, we can't foresee the future, so we never really know what's actually going to happen. What we can do is we can use past events to predict probabilities. For example, if I work, I'm a manager of a pretty good football team, and they tend to win, say, 70% of their matches, then the next match they're going to play, we could say has 70% chance that they're going to win. If I can't, for example, say with 100% certainty that the sun will rise tomorrow, for example, because who knows what happens out there? Maybe something will go wrong to the sun, and we can only really say 99.99999 whatever percent chance that the sun is going to happen. But I suppose basically, pretty much, if when we round it up, it would round up to 1 or 100%. That's just a small thing to say about these numbers at the beginning, and the other thing that tends to be covered in these probabilities is something called conditional. Well, actually, let's first of all look at combined probability. So I'll take something simple like I'm going to toss a coin. Now, if I'm going to what's the chance of me getting a head? Presuming it's a fair coin, it's going to be 50-50, right? So the chance of me getting heads is 0.5. Okay. Now, what's the chance of me getting 2 heads in a row? Well, okay, let's think about this. First of all, we can say what are the different combinations. So we've got. So let's say that this is our. I'll try to tidy that up a bit. I don't tend to be able to draw a horizontal line. So what I'm going to say is this is our first coin. No, sorry, this is our first event, and this is our second event. So this is the first coin toss, and this is the second coin toss. And these are the different eventualities. These are the different combinations, I guess. There's probably a keyword for it, but anyway. So this is my first. So option A, I could have head followed by head. Now that's the one that we're looking for, but that's not the only possibility, is it? I could get head followed by tails, or I could get tails followed by heads. Or in fact, I could get tails followed by tails. So there are 4 different combinations I could have got. And what was the probability of me getting the top option? Well, they're all just as likely as each other. So the probability of me getting head followed by a head is equal to 0.25, or if you like, 1/4. So if the first coin, we know that each event had 50% chance of it happening. So we could say H1, or the first one was 0.5, the second one was 0.5. What's the chance of both of them happening? Then what I've done, what it turns out you can do is you can just do 0.5 times 0.5. So this, so when we want to know, when we want two events happening, what's the chance of me having a head and then also of me, getting ahead and then also getting ahead a second time? The chance is 0.5 times 0.5. What would be the chance of me getting head only once out of those coin tosses? Well, looking at the table, we've got it looks like we're going to get 3 out of 4, so we should be getting 0.75. So what we do then is we look at all the different combinations, and we can say, well, it's going to be A, B, or C. So A, B, or C. If I was asked what's the probability of me getting just one head, at least one head, then A, B, or C. So in the first case, we're using and. What's the probability of me getting a head and a tail? Now we're using or. What's the probability of me getting just one head, which in other words is A or B or C? And we know the probability of each one is 0.25. When we do or, we add them. So it's going to be 0.25 plus 0.25 plus 0.25. So that's 0.75. So that's so when we are using and we'll look at some more examples of this in a moment. We multiply probabilities, and we're using or, like this happening. What's the probability of this happening or this happening? We add the probabilities. Let's imagine let's take a simple example with or. When I flip a coin, what's the probability of me getting a head or a tail? Well, it's going to be 0.5 for the head plus 0.5 for the tail, so 1. Okay, makes sense, right? What's the probability of me getting a head or a tail? It's definitely going to be one of them, unless it lands on its side. We're obviously with this, if we actually wanted to be really picky and so on, we could actually say, well, that's actually 0.49% of head, 0.49% of tail, and then whatever the remaining amount is for the for the landing on its side. But we're ignoring that, right? Okay. So let's have a look at some other examples. What about this is where probability trees come in. So I'll draw a probability tree of the situation I've just given. We have we've got the original coin toss, and we've got head or tail. That takes us now. So essentially, whatever event happens, we're going to be following along these lines. So we either go up here because we've tossed a head, or we go down here because we've got a tail. And then what's the next thing? It branches off again because it could be another head and it continue that direction, or it could be a tail and it continue in this direction. And then we end up with the eventuality of a head followed by a head, which we already know is 0.25. And the reason for that is because this is 0.5 and this is 0.5, and so we multiply them together. And this one is going to be head followed by tails, and then it's going to be tails, and so that's head, that's tails. Anyway, so you get the idea. Oh, I made a mistake. Look. And then tails followed by tails. So this is a probability tree. It's a very simple one, isn't it? And it really doesn't really make any sense to use a probability tree in this sense, because it's all 0.5. You don't really. It's a bit of an, but not really. Doesn't really make much sense. However, some cases it does. So let's imagine a written question. So I will. Basically, there's different ways of visualizing the situation. before I write this, actually, if you look, just imagine the first situation we've got. If I said, what's the probability of you getting 3 heads or 4 heads, you'd end up having this massive big table and trying to work out all the different combinations of different coin tosses. Whereas if you know this shortcut, then you can see what's the probability of me getting 4 heads. Well, it's going to be 0.5 times 0.5 times 0.5 times 0.5, or because the probability is always the same, 0.5 to the power of 4. And we could also do a tree diagram in that case, but again, there's not much point, is there? Because all the probabilities are the same. We can visualize it fairly quickly. Let's have a look at something that doesn't. So we got a football team. This is a classic one. I see football team probabilities always coming up in these exam questions. So a football team wins. Wins 70% of. Oh, I can't type. Of their matches, but if they have recently lost a match, they will the probability of winning. Actually, let's just make it a bit harder, shall we? Of losing the next one is we'll say 30%. No, not 30%. I say 35%. Okay. So this time we'll do a probability tree. So we've got them starting off with their first match. What happens? Do they win or do they lose? Now, we don't know, obviously, but we're looking at the different combinations. So the 70%, we're going to turn that into 0.7. Now, we could leave it at 70%, but they generally do probabilities in decimals, so we'll do that. Now, losing would be the rest of it. So you see, they're either going to win or lose. Okay. Could they draw? Let's say they could draw. Okay, then we're going to pretend that in this. I've obviously chosen a bad example. We're going to pretend that in this game, let's pretend it's not a football match. They can't draw. Okay, there's some sort of penalty shootout. Let's say there's a penalty shootout, which means that no drawing is possible. So the probability of them losing is 0.3. So let's take the eventuality that they have won. They now the probability of them winning the next match is still 0.7. So winning is 0.7. And losing that match would be 0.3 again. However, you take the situation where they have lost a match, now we said that the probability of them losing again would be would be 35%, which would be 0.35, which means that the probability of them losing winning this second match, because after they've lost the first one, is actually going to be diminished. 0.65. Okay, so maybe you might say something like, what's the probability of them winning one of the matches? Maybe let's say, what's the probability of them winning only one of the matches? Well, it's going to be this and this, so 0.7 times 0.3. That would give them that eventuality, win, lose. Or, which means we use a plus, they lose the first. They lose the first, and then they win the second. So 0.3 times 0.65 this time. Okay. So let's tap that into our calculator, and there you go. So the chance of them winning just one match ends up being 0.405. Now, what I did is I took this first bit. 0.7 times 0.3 is 0.21. Take the second bit, 0.3 times 0.65 is 0.195. Then added them together because we're saying either this happening or this happening. So we add them together, it's 0.405. So that is a brief introduction to probabilities. So we'll stop the video there.